In 2025, humans will have a unique opportunity – travel to the Moon. So far, only 12 people have walked on Earth's natural satellite, but a private company is offering tourists a chance to change that. If you are hog-stinky rich, you can pay $750 million to spend several days exploring the Moon and watching Earth from a distance. You can even join unique scientific experiments. Now, humans also want to build their forever homes on the Moon. In fact, NASA believes that North Americans may have their own share of the Moon by 2040. And you don't even need to be an astronaut to buy a plot of land on the Moon. Of course, billionaires are already making plans. Their first idea is to exploit natural resources. The Moon is packed with stuff that is rare here on Earth, like helium-3 and many rare Earth minerals, or more precisely, rare Moon minerals. But I digress. Hey, if you can get your hands on some of it, you may get even richer. First, helium-3. It's great for clean nuclear energy, but it's super rare on Earth because it escapes into space. The Moon, though, has tons of it, enough to power Earth for 1,000 years. Rare Earth minerals are not actually rare on Earth, but they're hard to mine because they react with oxygen. On the Moon, hey, there's no oxygen, so we could easily get loads of these materials to make better tech, like electronics and batteries. Scientists aren't thrilled about this. For the first time, they have a chance to explore 4.5 billion years of space history. Because the Moon's soil has stayed the same for billions of years. Studying its rocks could reveal lots of secrets about the universe's origins. But if billionaires mine the Moon and destroy these rocks, all that knowledge could be lost forever. Another problem with exploring the Moon is the size of it. The Moon is big, but the best spots, the ones with water and sunlight, are limited. Most of the lunar surface is dangerous because of earthquakes or moonquakes, radiation, and meteorites. That means tourists, scientists, and mining companies would be elbowing each other in 3 small regions. The first region is called the Peaks of Eternal Light because there's always sunlight over there, making it a great energy source for telescopes or human colonies. The second spot is the far side of the Moon. Here, radio signals from Earth are not so strong. It's not just peaceful and quiet there. It's also a great place to set up a telescope and study the universe. The third place is called the Pits of Eternal Darkness. It's where all the trolls on social media go on vacation. Nah, it's really because no sunlight reaches that area. This place is even better for scientists because they can use special astronomy tools to study the most distant parts of the universe. This is also where you can find about 1 billion tons of water. If scientists could visit the Moon and study it, they would make amazing discoveries. But today, there are no international laws protecting space. No country can own the Moon, but this can't stop a private mining company from calling dibs on a particularly good spot. In the past, a bunch of nations signed the Outer Space Treaty, and they agreed that space exploration was supposed to benefit all humankind. But exploring it is not cheap in the first place. Taking a single gallon of water from the Moon to the Earth is extraordinarily expensive, and I bet not everyone can afford that. Human activity on the Moon is also extremely dangerous because it might change its atmosphere. Now, to understand it better, let's look at the surface of the Moon. This floating rock has many craters that have been forming for billions of years. When a meteorite crashes into the Moon, fine dust called regolith, with particles so tiny they can cut like glass, rises into the air. This process once created the atmosphere of the Moon, and this atmosphere is quite different from the atmosphere of Earth. A big rocket landing on the Moon can launch this fine dust into the lunar sky, and the difference here is that the space objects crashing into the lunar surface are actually gentler. A rocket landing is so intense it can increase the number of atoms in the sky 100,000 times. If the number of atoms in the atmosphere grows, the air turns into a dusty plasma. This means that you'll be breathing in air as toxic as the one that poisoned miners in the olden days. Such an atmosphere could end space tourism too, because it makes electronics malfunction and machinery shut down. Well, truth be told, our own presence on the moon is already dangerous. When scientists discovered water on the surface of the moon, they were super excited to study it. This was their chance to understand where this water came from, and even figure out how water appeared on Earth. But when our spacecraft land on the moon, outgassing occurs. This means that the water on the surface evaporates. This evaporated water can contaminate the water on the moon, ruining all scientific data. Because when astronauts take a sample of the lunar water to study it, they will get the water from Earth they have brought along. Bummer, really. And it's not just the water we contaminate, it's everything. A spaceship can carry any living thing from Earth to the moon. It can also bring extraterrestrial life forms back to Earth. This type of contamination is extremely dangerous because it can put human lives at risk. Something similar happened when Europeans were exploring unfamiliar lands they came upon in the Americas. They accidentally introduced new microbes to the natives they met. And since the immune systems of the native population were not used to those new bacteria and viruses, they got sick and worse. At the same time, Europeans also became ill with diseases their bodies didn't know about yet. And even though moon tourism is not happening yet, humans are already littering the lunar highlands like their own backyard. In 2024, an artist named Jeff Koons sent a sculpture to the moon. The sculpture is a transparent box filled with spheres, and it got to the moon thanks to a ride on a SpaceX Falcon 9 rocket. In each sphere, Koons engraved the name of a human he considered super important to humankind, like Aristotle, David Bowie, and Leonardo da Vinci. Thankfully, you don't have to go all the way to the moon to see this sculpture. You can purchase an NFT of each sphere. Or not. Back in 1971, the crew members of Apollo 15 also left a couple of things on the moon. A figure created by a Belgian artist and a commemorative plaque to honor other astronauts who couldn't be there. And it's not just art that humans dumped on the moon. If you take a walk, you might just stumble upon 413,000 pounds of materials left behind, including a gold olive branch, a falcon feather, a silver astronaut pin, a Bible, some golf balls, a hammer, and even leftover urine collection kits. Most of this stuff was left behind by the astronauts that explored space between the 60s and 70s. So you can find moon rangers, lunar probes, and orbiters that are decades old already. Now, to be fair, bringing back unnecessary equipment costs a ton of money. And back in the 60s, their priority was the safety of the astronauts. The sad truth is that the moon is already turning into an extraterrestrial landfill, and we don't even live there yet. But now we want to settle there, so NASA is trying to get rid of all this trash. The good news? Hey, you can be part of this process. The space agency launched a competition called the Luna Recycle Challenge. And if you want to join it, you must find ways to reduce the amount of litter produced and recycle it into materials that can be used for space exploration. To win, you need to develop a way to completely recycle the trash that is on the surface of the moon. You will help science and win $3 million. And if you get this sum, well, you might finally afford a ticket into space.
What if our moon was hollow? Would we be able to hide inside in case some terrible catastrophe destroyed our home planet? Well, the supporters of the hollow moon theory believe that it's actually a real option. The hollow moon is a hypothesis claiming that Earth's moon is either completely hollow or has quite a lot of place inside. The thing is, the moon is less dense than Earth, and it seems to support the idea of its hollowness. But according to science, the reason is the fact that Earth's upper mantle and crust are less dense than the heavy iron core of our planet. Then, there's also the claim that the moon rings like a bell. For almost a decade, between 1969 and 1977, seismometers installed on the moon by the Apollo missions kept recording moonquakes. The moon was reported to be ringing like a bell during such quakes, especially shallow ones. On the 20th of November, 1969, Apollo 12 deliberately crashed the ascent stage of its lunar module into the surface of our natural satellite. According to NASA, after that, the ringing continued for almost an hour. This made some people argue that the moon must be hollow like a bell. Later, lunar seismology researched those shallow moonquakes and showed that they acted differently than quakes on our planet, mostly due to differences in type, texture, and density of the lunar and Earth's rock layers. The speed of sound waves in solids is determined by the medium's compressibility and density. No one has ever found any evidence of a large empty space inside the moon. And still, in 1970, Michael Vasson and Alexander Sherbakov suggested a hypothesis that the moon could be a spaceship designed by mysterious extraterrestrial beings. In 1965, writer Isaac Asimov made an observation that added fuel to the fire of conspiracy theories. He marveled at the sheer astronomical accident that the moon fits so snugly over the sun during total eclipses. The sun's greater distance makes up for the incomparably larger size of the star. As a result, it seems to us that the moon and the sun are the same size. The author added that there was no astronomical reason why the sun and the moon should fit so well. So since the 1970s, conspiracy theorists have been quoting Asimov's words about solar eclipses as evidence of the artificial origin of the moon. Mainstream astronomers disagree with such an interpretation, saying that the angular diameters of the moon and the sun don't perfectly match during eclipses. They vary by several percent over time. Many other pieces of evidence confirm that the moon is a solid body that formed after a planetoid crashed into Earth. In the past, scientists thought that the moon appeared after our rapidly spinning planet got rid of a good chunk of its mass. This idea was suggested in 1879 by George Darwin, the son of the very Charles Darwin, the famous biologist. This theory remained popular until the Apollo missions. Then, in 1925, Austrian geologist Otto Ampferer offered another idea, that Earth and the moon could have formed together from a primordial accretion disk, a rotating disk of dense gas and dust surrounding a young, newly formed star, and used to be a double system. The third theory stated that the moon could have once been a planetoid caught by the gravity of our planet. The modern explanation usually involves the giant impact hypothesis. According to it, a Mars-sized space body hit Earth and created a debris ring around our planet. In the end, this ring gathered into a single natural satellite, our moon. But getting back to the hollow moon theory, at the moment, there's no scientific evidence to support this hypothesis. Seismic observations and other data indicate that the moon has a solid interior with several layers, a thin crust, quite extensive mantle, and a dense core. These days, the idea of the hollow moon is considered to be a conspiracy theory.
There are a few theories about how the moon appeared in the sky, and recently a new idea has popped up. But before we discuss this newcomer, let's look at the most popular hypotheses of the moon's formation. The capture theory claims that Earth's natural satellite used to be a wandering body, something like a large asteroid. It had formed somewhere else in the solar system before it was captured by our planet's gravity when passing nearby. The accretion hypothesis suggests that the moon formed in orbit around Earth at the same time as our planet appeared in the darkness of the cosmos. Then, there's the fission theory that says that at one point in its development, Earth was spinning so fast that some of its material broke away and started to orbit the planet. And the giant impact theory, which is the most popular these days, claims that the moon formed during a collision between Earth and another hypothetical planet called Theia, which was way smaller, probably the size of Mars. The resulting debris collected in an orbit around Earth and formed the moon. And now, let's move to the new theory you've been patiently waiting for. According to it, our satellite might have formed immediately, in a matter of hours, after the collision between Earth and Theia. The material from the two planets was likely launched directly into Earth's orbit right after the impact. It formed the moon and left traces deep inside Earth. In previous scenarios, Theia's remains were thought to have been scattered all over space, mixing with just a bit of the material coming from our own planet. But then, why do we see such shocking similarities between the moon's and Earth's compositions? Could it be that Theia was isotonically and chemically similar to Earth? Unlikely. But according to the new theory, more material from Earth was used to create the moon, its outer layers in particular. It might explain this similarity in composition. One more theory also tries to explain this mysterious similarity, the synestia model. According to it, our satellite formed inside a swirl of vaporized rock left by the collision. But this theory can't explain the moon's current orbit. The new single-stage theory does offer us plausible explanations for both the similarities in composition and the orbit of the moon. It might also provide us with some answers to previously unsolved mysteries. Since this scenario puts the moon into a wider orbit and gives it an interior that is not fully molten, it can explain the satellite's tilted orbit and thin crust. In any case, to confirm one of these theories, we need to analyze future lunar samples that will be brought to Earth by NASA's upcoming Artemis missions. Scientists will be able to get their hands on some material from deeper beneath the moon's surface and compare if real data matches these simulated scenarios. In the past, the Apollo missions already brought back about 1/3 of a ton of rock and soil from our satellite. These samples showed that Earth and the moon had some remarkable chemical similarities. They could only suggest one thing. These space objects had a linked history. If the moon had formed elsewhere and been captured by our planet's gravity later on, its composition would be very different from that of Earth. But if the moon had been created at the same time as Earth, or if it had broken off our planet, the type and proportion of minerals on the moon would be the same as on Earth. But they are a bit different. The moon's minerals contain less water than their terrestrial counterparts. The satellite is also richer in materials that form rapidly at high temperatures. That's why the most accepted model of the moon's formation these days is the giant impact model. Meteorites coming from the moon are a great source of data for studying the origins of our satellite too. They can tell us even more about the moon than Apollo samples, all because such meteorites come from all over the surface of the moon. Meanwhile, Apollo samples were collected just in one place near the equator on the near side of the moon. Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples. And this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, Scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us, or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
Technological progress does not stand still, and over the past decade, the resolution of images of the lunar surface has improved greatly. Many pits have been discovered on the surface, and some of them are really impressive in size. The largest are hundreds of feet deep. However, technology is not yet advanced enough for us to study the bottom of such pits in detail. That's why a recent discovery is surprising. It turns out that huge pits can extend deep into the rock of the moon. It's a groundbreaking discovery. Let's figure out why. So look at this giant underground cave. Leonardo Carrere and Lorenzo Bruzone from the University of Trento were thrilled to finally confirm the existence of such structures on the moon. They analyzed images taken by the mini RF instrument on board the Lunar Reconnaissance Orbiter in 2010. The original images didn't have excellent resolution, so the authors had to do a huge amount of work, using modern data analysis and modeling techniques. But first things first, why does it all matter so much? Well, instead of building homes on the surface of the moon, we might be able to live inside these natural caves. They could offer protection from dangerous things like harmful space radiation, extreme temperature swings, and even meteorites. According to planetary geologist Wes Patterson from Johns Hopkins, even though we'd still have to bring materials from Earth to make those caves habitable, using them would be a lot easier and cheaper than building bases on the surface. Based on the collected data, the cave is about 150 feet wide and up to 260 feet long, which is just a bit smaller than a football field. It's located in a deep pit called the Mare Tranquillitatis Pit, which likely formed when an ancient lava tube collapsed. Although the moon has no active volcanoes today, billions of years ago, its surface was covered with lava that flowed through valleys, carving out these tubes below the surface. Over time, some of the lava tubes became unstable and collapsed, creating pits like the one in question. NASA's Lunar Reconnaissance Orbiter, LRO, has already found more than 200 of such pits on the moon. It means there could be hundreds of hidden caves waiting to be explored on our satellite. When publishing their findings in Nature Astronomy, the researchers suggested that the caves could offer future astronauts a safe place to live and work, protecting them from the moon's extreme conditions. And extreme they are. One of the biggest challenges of living on the moon is its temperatures. The lunar surface gets extremely hot during the day, reaching about 250 degrees Fahrenheit, and then the temperature drops below minus 200 degrees Fahrenheit at night. but inside the caves, the temperature could stay much more consistent. A separate study done in 2022 used computer simulations to predict that some of those caves could maintain a comfortable temperature of about 63 degrees Fahrenheit. Much easier to manage, right? Unfortunately, getting to the caves won't be easy. The Mare Tranquillitatis cave is over 400 feet below the surface, at the bottom of a steep slope covered in loose debris. It would take some clever engineering to get up and down that slope. The options could be using jetpacks, a lunar elevator, or some other kind of technology. We must find a way to transport astronauts safely. There's also a lot more to discover. Radar technology could help scientists find even more caves and lava tubes on the moon. In the future, a spacecraft with higher resolution radar could even map the insides of the pits that LRO has already found. According to the researchers, this kind of complete survey could help them figure out the best locations for future lunar bases and other explorations. And there's another potential bonus. Those caves could contain water. Scientists have already found frozen water on the moon, under the surface, and in permanently shadowed craters. Tiny amounts are also scattered across the lunar dirt. Water is a critical resource for any moon base, and finding it in the caves could make the idea of living there even more realistic. All in all, this discovery could be a game changer for lunar exploration. Living in natural caves on the moon might be a more practical and safer option than building something on the surface. It could also bring us one step closer to making the moon a place where humans can live and work for the long term.
There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers: a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both GRAIL and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquilitas, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
Our moon exploration project started out in 1969. Sure, there have been some problems along the way, but astronomers are certain we'll get back up there pretty soon and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're going to make a map system for the moon, we need to do the same for its shape, called a solenoid, or what scientists call the moon's version of our Earth's shape. Since the moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades and even some exciting trips we might end up having on the moon, we need to be more precise. Scientists now believe we should get the real data and start drawing an accurate picture of the moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball. Scientists recently used it to map around 100,000 spots on the moon using data previously collected by NASA. And what they found was crucial for our understanding of the moon's shape. For instance, we now know that our satellite's poles are about 0.3 miles closer to the center compared to the moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the moon, but we already know it works wonders here at home, so it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits? So, he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers. 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while. But its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8, 13. Pick any two numbers side by side. Say 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected. But if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers. If that's really the case, then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid's shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our bodies seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs. Our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand. The wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve, and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out, and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, gravity just smushes it all into an egg shape, or what the astronomers call elliptical.
Technological progress does not stand still, and over the past decade, the resolution of images of the lunar surface has improved greatly. Many pits have been discovered on the surface, and some of them are really impressive in size. The largest are hundreds of feet deep. However, technology is not yet advanced enough for us to study the bottom of such pits in detail. That's why a recent discovery is surprising. It turns out that huge pits can extend deep into the rock of the moon. It's a groundbreaking discovery. Let's figure out why. So look at this giant underground cave. Leonardo Carrere and Lorenzo Bruzone from the University of Trento were thrilled to finally confirm the existence of such structures on the moon. They analyzed images taken by the mini RF instrument on board the Lunar Reconnaissance Orbiter in 2010. The original images didn't have excellent resolution, so the authors had to do a huge amount of work, using modern data analysis and modeling techniques. But first things first, why does it all matter so much? Well, instead of building homes on the surface of the moon, we might be able to live inside these natural caves. They could offer protection from dangerous things like harmful space radiation, extreme temperature swings, and even meteorites. According to planetary geologist Wes Patterson from Johns Hopkins, even though we'd still have to bring materials from Earth to make those caves habitable, using them would be a lot easier and cheaper than building bases on the surface. Based on the collected data, the cave is about 150 feet wide and up to 260 feet long, which is just a bit smaller than a football field. It's located in a deep pit called the Mare Tranquillitatis Pit, which likely formed when an ancient lava tube collapsed. Although the moon has no active volcanoes today, billions of years ago, its surface was covered with lava that flowed through valleys, carving out these tubes below the surface. Over time, some of the lava tubes became unstable and collapsed, creating pits like the one in question. NASA's Lunar Reconnaissance Orbiter, LRO, has already found more than 200 of such pits on the moon. It means there could be hundreds of hidden caves waiting to be explored on our satellite. When publishing their findings in Nature Astronomy, the researchers suggested that the caves could offer future astronauts a safe place to live and work, protecting them from the moon's extreme conditions. And extreme they are. One of the biggest challenges of living on the moon is its temperatures. The lunar surface gets extremely hot during the day, reaching about 250 degrees Fahrenheit, and then the temperature drops below minus 200 degrees Fahrenheit at night. But inside the caves, the temperature could stay much more consistent. A separate study done in 2022 used computer simulations to predict that some of those caves could maintain a comfortable temperature of about 63 degrees Fahrenheit. Much easier to manage, right? Unfortunately, getting to the caves won't be easy. The Mare Tranquillitatis cave is over 400 feet below the surface, at the bottom of a steep slope covered in loose debris. It would take some clever engineering to get up and down that slope. The options could be using jetpacks, a lunar elevator, or some other kind of technology. We must find a way to transport astronauts safely. There's also a lot more to discover. Radar technology could help scientists find even more caves and lava tubes on the moon. In the future, a spacecraft with higher resolution radar could even map the insides of the pits that LRO has already found. According to the researchers, this kind of complete survey could help them figure out the best locations for future lunar bases and other explorations. And there's another potential bonus. Those caves could contain water. Scientists have already found frozen water on the moon, under the surface, and in permanently shadowed craters. Tiny amounts are also scattered across the lunar dirt. Water is a critical resource for any moon base, and finding it in the caves could make the idea of living there even more realistic. All in all, this discovery could be a game changer for lunar exploration. Living in natural caves on the moon might be a more practical and safer option than building something on the surface. It could also bring us one step closer to making the moon a place where humans can live and work for the long term.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days. or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Technological progress does not stand still, and over the past decade, the resolution of images of the lunar surface has improved greatly. Many pits have been discovered on the surface, and some of them are really impressive in size. The largest are hundreds of feet deep. However, technology is not yet advanced enough for us to study the bottom of such pits in detail. That's why a recent discovery is surprising. It turns out that huge pits can extend deep into the rock of the moon. It's a groundbreaking discovery. Let's figure out why. So look at this giant underground cave. Leonardo Carrere and Lorenzo Bruzone from the University of Trento were thrilled to finally confirm the existence of such structures on the moon. They analyzed images taken by the mini RF instrument on board the Lunar Reconnaissance Orbiter in 2010. The original images didn't have excellent resolution, so the authors had to do a huge amount of work, using modern data analysis and modeling techniques. But first things first, why does it all matter so much? Well, instead of building homes on the surface of the moon, we might be able to live inside these natural caves. They could offer protection from dangerous things like harmful space radiation, extreme temperature swings, and even meteorites. According to planetary geologist Wes Patterson from Johns Hopkins, even though we'd still have to bring materials from Earth to make those caves habitable, using them would be a lot easier and cheaper than building bases on the surface. Based on the collected data, the cave is about 150 feet wide and up to 260 feet long, which is just a bit smaller than a football field. It's located in a deep pit called the Mare Tranquillitatis Pit, which likely formed when an ancient lava tube collapsed. Although the moon has no active volcanoes today, billions of years ago, its surface was covered with lava that flowed through valleys, carving out these tubes below the surface. Over time, some of the lava tubes became unstable and collapsed, creating pits like the one in question. NASA's Lunar Reconnaissance Orbiter, LRO, has already found more than 200 of such pits on the moon. It means there could be hundreds of hidden caves waiting to be explored on our satellite. When publishing their findings in Nature Astronomy, the researchers suggested that the caves could offer future astronauts a safe place to live and work, protecting them from the moon's extreme conditions. And extreme they are. One of the biggest challenges of living on the moon is its temperatures. The lunar surface gets extremely hot during the day, reaching about 250 degrees Fahrenheit, and then the temperature drops below minus 200 degrees Fahrenheit at night. But inside the caves, the temperature could stay much more consistent. A separate study done in 2022 used computer simulations to predict that some of those caves could maintain a comfortable temperature of about 63 degrees Fahrenheit. Much easier to manage, right? Unfortunately, getting to the caves won't be easy. The Mare Tranquillitatis Cave is over 400 feet below the surface, at the bottom of a steep slope covered in loose debris. It would take some clever engineering to get up and down that slope. The options could be using jetpacks, a lunar elevator, or some other kind of technology. We must find a way to transport astronauts safely. There's also a lot more to discover. Radar technology could help scientists find even more caves and lava tubes on the moon. In the future, a spacecraft with higher resolution radar could even map the insides of the pits that LRO has already found. According to the researchers, this kind of complete survey could help them figure out the best locations for future lunar bases and other explorations. And there's another potential bonus. Those caves could contain water. Scientists have already found frozen water on the moon, under the surface, and in permanently shadowed craters. Tiny amounts are also scattered across the lunar dirt. Water is a critical resource for any moon base, and finding it in the caves could make the idea of living there even more realistic. All in all, this discovery could be a game changer for lunar exploration. Living in natural caves on the moon might be a more practical and safer option than building something on the surface. It could also bring us one step closer to making the moon a place where humans can live and work for the long term.
Neil Armstrong had been getting ready for his mission on the moon for over 3 years. To resist microgravity conditions, he had to learn how to walk sideways by being strapped and suspended at an angle in trying to walk along walls. His limits were tested through an intense diet and sleep regimen, since in space he would only have beef and vegetables, previously dehydrated and stuffed into a package. Back in the day, astronauts had to experience the desert, jungle, open sea, and Arctic survival training. These days it's a lot more structured. But back then, it was more of a let's drop this person in the middle of nowhere with no supplies and see if they make it. Before landing on the moon, he had to gather and study rock samples in the Grand Canyon, explore ancient volcano formations in the Nevada National Security Site, and look into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. On July 20th, 1969, Armstrong was given a hearty breakfast before blastoff. Steak, eggs, toast, juice, and coffee. He received what doctors call a low-residue meal, which means he wouldn't have to go to the bathroom soon after. It took him 109 hours and 42 minutes to reach the surface of the moon, in an area called the Sea of Tranquility. He had to travel 240,000 miles to get there. The crew could have gone for the Ocean of Storms or the Central Bay, but this place was chosen for landing because it had good visibility, was relatively smooth, and was easily reachable with as little propellant as possible. When he was at about 500 feet above the surface of the moon, Armstrong had to maneuver the spacecraft manually to make sure they wouldn't land in a dangerous crater. He continued to hover for about a minute and a half, moving it sideways until he felt comfortable to land. As soon as his device landed safely, he immediately radioed to Mission Control, located in Houston, Texas. The now famous message,
"The Eagle has landed."
Steadily, he went down the lunar module's ladder, while a television camera was attached to the craft to record his progress. The camera also transmitted the signal back to Earth, where hundreds of millions of people were anxiously waiting. At precisely 10:56 p.m. EDT on the same day, Armstrong placed his feet onto the lunar soil, saying,
"It's one small step for man, one giant leap for mankind."
The schedule said that the astronaut needed to sleep before the first moonwalk, but he chose to go outside earlier than planned, since he obviously couldn't sleep. If Armstrong had walked on the moon without special equipment to breathe, he would have smelled a weird odor, sort of musty and sulfuric. Still, he had the chance to smell it when he returned to the lunar module. The thing is, the dirt had clung to his feet, so the odor spread all over the cabin. He described it as wet fireplace ashes, or how the air smells after fireworks shows. Who would have thought you needed to pack a scented candle when going to the moon? Apart from the people that have since made it to the moon, no one ever got the chance to know precisely what the crew was smelling. Even during that first mission, when moon soil and rock samples were transported to labs in airtight containers, once they were opened back on Earth, surprisingly, the smell was gone. He also felt the surface of the moon to be fine and powdery, but said he had no difficulty in moving around. One other member of his crew joined him about 20 minutes later. The whole moonwalk took a little over 2 hours. During this time, Armstrong and his teammates set up various devices on the surface of our satellite. One was meant to precisely measure the exact distance from there to Earth, by timing how long it took for a laser beam to travel from Earth to the lunar surface and back. Another meant to measure moonquakes and potential meteor impacts, which leads us to the discovery that the moon was pretty alive after all. We know today that the largest moonquakes are much weaker than the largest earthquakes, though their movements can last for up to an hour, way longer than on Earth. They managed to gather somewhere around 50 pounds of rock and soil samples. They also snapped many photographs of the terrain, where they also planted a US flag. The astronaut even got the chance to catch up with President Richard Nixon, for less than a minute though. The final thing on the list for Armstrong was to go for a walk to what is now known as East Crater, 65 yards east of the lunar module. It was the greatest distance traveled from the spacecraft on that specific mission, approximately the length of half a football field. As soon as his tasks were done, Armstrong went back into the lunar module and safely closed the hatch to get some sleep. While preparing for liftoff, Armstrong and his crew discovered that, because of their chunky spacesuits, they managed to break the ignition switch for the ascent engine. No big deal, they thought. So they used a part of a pen to push in the circuit breaker to start the launch sequence. At 1:54 p.m., the famous Eagle began to ascend. Apart from the scientific equipment installed on the surface of the moon, a plaque was also left there. It read, "Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." Years later, Armstrong said that NASA limited their time on the moon because they didn't know how the spacesuits would handle the moon's extreme temperatures, as high as 260 degrees Fahrenheit during the day, to as low as 280 degrees Fahrenheit below zero at night. Things got a bit more complicated when Armstrong landed back on Earth, since he had been exposed to unknown space particles. The result? He and his team had to be placed in planetary protection quarantine on their return, as soon as their space capsule safely splashed down in the Pacific Ocean on July 24th. That specific quarantine for the Apollo 11 astronauts is one of the reasons why we have microwaves in our kitchens today. When they first returned from the moon, they initially spent their first few days in a mobile quarantine facility, or MQF. Sure, the MQF featured comfortable chairs, bunks, a toilet, and showers, but it didn't leave a lot of space for fancy cooking. Since there was no room for a standard oven or grill, and to also reduce the potential fires that might have occurred, NASA had to get creative. That's how the original countertop microwave oven was developed, to easily help astronauts get their meals without the hustle of a fully equipped kitchen. These days, you can see that first microwave in a museum in Oakland, California. After returning to Earth, Armstrong claimed he would never reach for the stars again. But he didn't stop exploring though. Back in 1985, he joined a professional team of other greatest explorers to the North Pole. He was joined by mountaineer Edmund Hillary, aviator Steve Fawcett, and photographer Patrick Morrow, reaching the pole on April 6, 1985. Armstrong claimed he wanted to see what the Earth's icy pole looked like from the ground, since he had only seen it from the surface of the moon. The Apollo 11 mission was nevertheless unforgettable for Armstrong since. In 2015, the Smithsonian Institution uncovered that he had kept hidden a cloth bag full of small parts from the lunar module. It included his waist tether, some utility lights, and their brackets, an emergency wrench, and the optical sight that was mounted above Armstrong's window of the space module. It also contained the data acquisition camera that recorded the iconic footage of Armstrong taking his small step on the moon. Armstrong kept it to himself for many years until his widow, Carol, eventually found it. He even kept it a secret from his official biographer, who had many times asked if he had kept any memorabilia from his famous mission. He didn't sneak those objects back on Earth, though. He just mentioned it to be a bunch of trash he wanted to bring back.
About a century ago, people envisioned the 21st century as a time filled with quirky inventions. They weren't far off the mark. We're now one step closer to establishing an actual settlement on the moon. Before we can create a new home up, we need to find a way to stay connected, beyond just transportation and shipping. Being able to send a simple text, even something as casual as, "Hey, how are you?" is essential. We can't move to the moon if we're cut off from Earth. Let me spill some tea. A lunar 4G network is currently being developed. The company leading this initiative is none other than Nokia's Bell Labs. The company, bought by the world-famous Finnish company that started out as a paper mill in the 19th century and later ventured into the cell phone industry, creating iconic devices long before Apple launched its first phone. Once the network is completed, it will be loaded onto a lander, deployed, and connected using specialized radio equipment. But don't think this is just a fun experiment. It has significant purposes. The Lunar Outpost rover, one of the vehicles involved in this mission, will thoroughly explore an area known as the Shackleton Connecting Ridge. Another rover, the Micronova, will investigate a lunar crater in search of ice. When they discover ice and capture images, this information will be first transmitted to the lander and then relayed to Earth, an unprecedented achievement in history. Moreover, the importance of a reliable phone connection cannot be overstated. Currently, astronauts communicate via radio. But NASA aims to establish a lunar communication system capable of supporting high-resolution video. Effective communication during space missions is as crucial as food and water, and with this new lunar 4G technology, video calls on the moon could soon become a reality. Plus, thanks to lunar 4G, we'll be able to track how the endangered species sent to the moon are doing. Oh, sorry, I completely forgot to mention something important. As more species edge closer to extinction today, scientists are collecting samples from animals, plants, and other organisms to store in biorepositories around the globe. Unfortunately, the conditions on Earth are far from ideal for these modern-day Noah's Arks. Hence, the decision to build 1 or 2 vaults on the moon makes perfect sense. On the moon, there's a permanently shadowed region at its south pole. It may seem like a fortunate coincidence, but some lunar craters may meet the criterion of temperature, -320 degrees Fahrenheit, which is precisely what we need for long-term self-storage. Initially, the plan was to construct the vault in lava tubes that run beneath the moon's surface, but that would have posed significant risks. This design requires a special solar-powered cooling system, and any accidental loss of power could be catastrophic, resulting in the destruction of all the samples. However, if we built it in a forever frozen shadowed area, the vault wouldn't need any energy or human maintenance. Bingo! It sounds almost too good to be true, and indeed there are several complications. For instance, dust is an omnipresent issue on the moon, infiltrating everything. If the storage requires seals, a dust mitigation system must be developed, which has not yet been created. So for now, it remains a theoretical concept rather than a practical solution.
40, 50 feet, why don't you turn around and let them get a view from there and...
I know you want to learn about real things, not just concepts. Here's something real for you. The moon is full of human waste, carefully packed into bags. According to estimates, there are around 96 of these bags you'd probably prefer to never open. But you never know what exactly is hidden inside. It could be any product of the human body out there. So, if we ever make it to the moon and you accidentally stumble upon a mysterious bag, my advice is to resist the urge to open it. Instead, you can hand it over to scientists. They say they're eager to get their hands on them. Humans are incredible, in a rather unfortunate way. We haven't even established a proper settlement on the moon yet, but there's already around 200 tons of junk scattered about. It piles up there as if it were a teenager's room rather than a celestial body. Alongside those rather unappealing human waste bags, you'll also find cameras, drills, towels, brushes, rakes, a multitude of other technical items, and, surprisingly, a falcon's feather. I'll explain that in a moment. At the end of Apollo 15's final moonwalk, David Scott pulled out a falcon's feather and a hammer to demonstrate Galileo's theory that in the absence of air resistance, different objects fall at the same rate. Amidst all that junk, there's an actual piece of art, So we could say that the moon, if it doesn't have the very first art museum, at least boasts a small exhibition. The crew of Apollo 15 took a 3.5-inch tall aluminum figure to the moon. Created by a Belgian artist, it's called the Fallen Astronaut, and it was laid on its side with a plaque listing the names of astronauts and cosmonauts who contributed to exploration. But the list of odd objects on the moon doesn't end there. If you ever find yourself in need of cash, you can find it on the moon, since a stack of $2 bills was simply forgotten there. Yep, a lot of material has been collected since 1969, when humans first stepped on the moon.
It's one small step for man, one giant leap for mankind.
Our natural satellite was first seen in a telescope in 1609. But what about its true age? To understand that, we need to start with how the moon first formed. Back in the mid-80s, a conference in Hawaii brought together a bunch of scientists to figure out where the moon came from. They came up with a pretty cool idea. The moon probably formed with the stuff that our planet Earth donated. Picture this. A Mars-sized object crashed into the early Earth, flinging molten materials into space, which eventually came together to become the moon we see today. This theory clears up a lot of mysteries. For instance, it used to baffle folks why the moon has such a small iron core. The answer is simple. It formed from Earth's outer layer, which isn't rich in iron. And that pale crust of the moon? It's just minerals that floated to the top when the molten moon cooled down. At first, the moon was super close to Earth, but it's been slowly drifting away at about 2 inches a year, even while you're watching this video. Figuring out when this all went down, though, is a bit tricky. The Apollo astronauts brought back a bunch of moon rocks, which helped scientists estimate their ages. The oldest ones are around 4.35 billion years old, which is about 200 million years after the solar system kicked off. So, here's the thing. There's no exact date for when the moon formed, but there are several interesting theories. One idea is that the age of these rocks could mean the moon is around 4.35 billion years old. But some scientists who look at how planets form think that most of the material in the early solar system came together way before that 200 million year mark. They argue that a big impact that created the moon happening that late seems pretty unlikely, which means the moon could actually be older than 3.5 billion years. Another interesting thought is that the moon might have gone through some serious heating events as it moved away from Earth. This is similar to what happens on Io, one of Jupiter's supervolcanic moons. The gravitational pull from a bigger body can stretch and compress a smaller one, generating heat, like when you squeeze a rubber ball. The rocks on both Io and the moon warm up this way. Rocks have radioactive elements that act like internal clocks, helping scientists figure out their ages. The catch is, if the moon heats up too much, it resets those clocks and only starts keeping time again once it cools down. So those rocks that are about 4.35 billion years old might not actually mark the moon's birthday. They could just indicate a time of tidal heating. This suggests, once again, that the moon had to have formed even earlier than that.
Time can stretch or shrink depending on where you are. Climb to the top of an extremely high mountain, and time will pass a teeny tiny bit faster than if you were down in a valley. That's all because of gravity and how it affects time. We hardly notice it in our everyday life, but for scientists and space agencies preparing to send people to the moon, these minuscule differences in time really do matter. We'll get to answer the why question a bit later. Right now, a new space race is underway. Many countries want to establish long-term bases on the moon. With humans up there, things like reliable timekeeping become crucial. The thing is, the moon doesn't operate on Earth's time. A day on the moon runs slightly faster than a day on Earth. The difference is about 56 microseconds, and it seems insignificant. But over time, even such a difference can add up, creating bigger issues. So, to keep lunar missions running smoothly and prevent things from drifting out of sync, NASA and scientists around the world are now dealing with a tricky challenge: creating an entirely new lunar time scale. NASA is supposed to start using it by 2026. It's the same year they hope to send astronauts back to the moon for the first time in 50 years. But this new time scale is not just a moon time zone. It's actually an entire system that will adjust for the moon's faster time and keep everything synchronized with Earth's time systems. Only in this case will missions be able to run smoothly. You see, on Earth our timekeeping is already surprisingly complicated. It might seem like time should be a straightforward concept, but keeping accurate time is actually a precise science, especially when you consider how much timekeeping affects our daily lives. So, to keep global time coordinated, scientists rely on something called Coordinated Universal Time, also known as UTC. This global time standard is based on ultra-precise atomic clocks that scientists place in separate locations all over the world. Atomic clocks are cool because they measure time based on the consistent vibrations of atoms, so they're super stable and accurate. This helps scientists make sure UTC is the same for everyone everywhere. These atomic clocks also take into account that time moves slightly more slowly the closer you are to the center of our planet. So, atomic clocks positioned closer to the Earth's surface tick a bit more slowly due to stronger gravitational pull. This effect, explained by Einstein's theory of relativity, happens because gravity affects time. By spreading atomic clocks across different elevations, scientists average out all the tiny time differences caused by gravity. Also, for precise timekeeping, scientists occasionally add leap seconds to account for the small natural changes in Earth's rotation speed. It sounds pretty technical, but this process of keeping everyone on the same time helps make the modern world function. After all, precise timing is crucial for global trading, GPS navigation, and even internet communications. But time on the moon works differently. Our natural satellite has a weaker gravitational field than Earth. That's why clocks on the moon tick a bit faster. This difference means that lunar clocks are very likely to slowly drift away from Earth clocks if there's no correction. It can lead to big problems when astronauts need to keep in close contact with Earth or navigate around the lunar surface. NASA's solution is something called a lunar time scale. Scientists aren't going to adjust moon clocks to match Earth exactly. Instead, they want to establish a unique system that measures lunar time accurately, but is also easy to convert back to Earth time. Think of it as creating a whole new framework just for the moon. To make this lunar time system work, NASA is cooperating with international colleagues like the European Space Agency. Together, they're setting up what they call LunaNet. This lunar network will be a bit like the Internet for the moon. It'll make sure all the lunar clocks work together and align with Earth-based time. Just like how atomic clocks around the world coordinate for UTC on Earth, clocks on the moon will be part of this larger LunaNet network. Now, scientists are pretty experienced when it comes to managing time in space. Global Positioning System satellites, which orbit Earth about 12,550 miles high, have atomic clocks on board. These clocks tick faster than clocks on the Earth's surface because they're quite far away from Earth's gravitational pull. But then, how does GPS navigation stay accurate? It's because scientists have figured out ways to slow those clocks down to match Earth's time. This experience with GPS clocks is a great base for what scientists need to do on the moon. In some ways, it might be even easier than managing GPS. Scientists can work with lunar clocks as they naturally are, instead of needing to adjust them to sync perfectly with Earth. By setting up accurate lunar time from the start, scientists hope to avoid some of the complications of managing GPS satellites. And now, here's the interesting part, or maybe more interesting. To keep lunar timekeeping a reality, NASA and its partners want to set up clocks both on the lunar surface and on satellites orbiting the moon. Some of these clocks will be long-lasting atomic clocks, and others will be crystal oscillators. Those offer stability over short time periods. Together, these clocks will create a network that scientists will be able to rely on. Meanwhile, atomic clocks for space don't come cheap. They can cost a staggering few $1 million each. Luckily, crystal oscillators are more affordable, but they don't stay accurate over long periods. Once those clocks are set up, they'll work together as part of LunaNet, which will be NASA's framework for everything related to moon-based time and data networks. LunaNet will act like an internet for lunar operations. Different space agencies will contribute to it, like how internet service providers work for us on Earth. But there's another set of challenges, and it's connected with the moon's rotation. Firstly, a day on the moon lasts much longer than a day on our planet because it takes the moon about 28 Earth days to make a full rotation. Plus, the moon's equator experiences about 14 days of sunlight, followed by 14 days of darkness, unlike Earth's regular day-night cycle. And at the moon's south pole, where NASA is going to establish future lunar missions, there are areas that stay lit or in shadow permanently. It might make it harder for astronauts to keep track of time. NASA and its partners hope to involve more countries in this project through international organizations like the International Astronomical Union. The idea is to get as many countries as possible on board with the lunar timescale, so that everyone exploring the moon is on the same page. Now, another really exciting thing about all this is that figuring out lunar time could help other future space missions, like trips to Mars. The experience and knowledge we'll get from setting up a lunar timescale are likely to serve as a blueprint for managing time on even farther planets. That's one of the reasons why scientists are taking this lunar project so seriously. As for astronauts living on the moon, a consistent, reliable time system will be essential, not just for navigation, but for everything from scientific experiments to day-to-day activities. NASA's Lunar Time Project is truly groundbreaking. It's the first step toward managing time as humans expand farther into space. And if they get it right, it'll mean that future astronauts won't just have Earth time to guide them. They'll also have a moon time, and even, one day, a Mars time too. Precise timekeeping matters both for the sake of scientifically understanding the passage of time on the moon and for setting up all the infrastructure necessary to carry out missions. Scientists are also eager to create a timescale from scratch because they can take everything they've learned about timekeeping on Earth and apply it to a new system on the moon. Well, I'm out of time, so bye!